Welcome to the introduction lecture of the Modeling and Programming course. My name is Jos Havinga. I will be giving the Modeling and Programming course, which is a course that runs through the full first year of the Mechanical Engineering Bachelor, and I also give the Statics course. And in this introduction lecture, I will tell you about the concepts of programming and about the organization of the course. So the content of the lecture is at first I will tell about the objective of the course and why we learn to program in an engineering studies. Then I will show applications and examples of programming in engineering. Then I will tell more things about several programming concepts. And then I will explain the organization of the course. And in the end, I will give some introduction to the specific programming code and program that we will be using in the mechanical engineering bachelor, which is MATLAB. So let's start with the learning objectives. And here are the objectives that you can find in Osiris for the Modeling and Programming 1 course. And we don't have to check all of them. The main objective is to learn how to write a program to solve engineering problems. So a question is, why do engineering students have to learn to program? And I hope to be able to show in the presentation and throughout the course in this full year that um, programming can help you to solve engineering problems which are very hard to solve by hand, or sometimes you will solve engineering problems which you can't solve on paper only. So if we would only do our engineering work with calculations on paper, then we wouldn't be able to design advanced structures and systems, and therefore we need the help of the computer to evaluate more complex problems. And in order to let our computer do that, we need some basic knowledge of programming. So in the Bachelor of Mechanical Engineering, learning to program is a tool for solving engineering problems. So that's a difference with computer science. In computer science, students learn to write programs. So they learn to program in a proper and advanced way. And in the mechanical engineering students, it's a tool. So we learn to solve engineering problems. We learn to interpret engineering results, and programming is a tool to do so. So I hope that you will be able to reach a programming level which allows you to use MATLAB to do certain calculations for you. So it's a tool, it's not an objective. So let's think about engineering, and let's think about engineering before computers. So people have been using computers in engineering for decades now, but there has been a lot of engineering before this time. So here I want to show some examples, and you can see the inside of a windmill here, which is quite of an advanced piece of Dutch engineering in this case, which was all done before the time of computers. We could also think about the Eiffel Tower, which was fully designed and constructed way before the first computer was invented. Also here you see the textile industry here in Twente, also a picture from more than 100 years ago. And also here they were using reasonably advanced machines to create pieces of fabric. And this is all engineering before the time of computers. And another example of an old locomotive. So if we think about this type of engineering, how was it, were people able to design reasonably sophisticated machines or products without the help of computer? Well, there are some main steps that had to be taken. So one thing is when doing calculation about the strength of the design or the dimensioning of the design, there had to be assumptions. So people had to simplify the problem in order to do some calculations in order to be able to design a proper machine. Also, at at that time it was needed to do more experiments sometime in order to figure out what the physics, uh, how how the laws of physics would apply on a certain machine. So if you can't figure it out with computers, you can do it with experiments. And then I will even show shortly a example of complicated calculations which were uh, done by human computers. So instead of a computer machine that we have nowadays, people try to do more complicated calculations by using multiple people to do certain calculations. So let's go through these examples first. So first here, um, an example of making assumptions, and this is very similar to what you see in the statics course. So in the design of this steel head frame from more than 100 years ago, uh, there was a certain design, and for the design there had to be made assumptions about how the forces will be in the system and how the wind load on the system will be. And then using such assumptions and using things as what we do in statics or what we will do in mechanics of materials, it is possible to make certain calculations by hand and use these calculations to dimension your structure, your frame. Also here, there's an example about um, experiments. Here's a picture from NASA, and yeah, at the time when they didn't have sophisticated computational fluid dynamics computers simulation models, then what they had to do more than what they do now. Nowadays it's still needed, but the amount of experiments that are needed in the design of such a system is much smaller because they can be replaced with computer experiments. But at that time, they had to do more simulations to figure out how this airplane, for example, behaves in the air. So this is an example of engineering before the time of sophisticated and fast computers as we have nowadays. And here's another nice example. This is a large-scale tabulating operation, which means that here was a large group of people who had to perform certain calculations. So there was some kind of method invented to let each one of them do a part of the calculation and then pass the result to the next person. So there was a certain workflow, and using a very specific workflow with having the need for all these people to do the calculations in a very accurate way, then it was possible to do reasonably complicated calculations with a group of persons. And nowadays, such a group of persons can be replaced by a simple computer, so and a simple program. And here's another example of what human computers could do. So doing the calculations that we do nowadays with programming, similar calculations were done when the Afsluitdijk was designed in the Netherlands. In the past, the IJsselmeer, so the large lake that you see here, it was just connected to the sea. So this is an old picture or an old map from the Waddenzee, so from our sea at the north of the Netherlands, and at some point the government decided to close the sea in order to have a big lake here, and the calculations were uh, done by the famous engineer Lorentz, and what he did is he developed a certain way to solve the mathematical equations that were needed to figure out how the tide would behave given a certain design of the dam. So this dam could be positioned, must be positioned at a certain place, and in order to figure out what the best place to position the dam is, he he made some simplifications in the calculations, and then he designed a certain method to do these calculations. And so to include the hydrodynamic equations that are needed to figure out how the tide behaves given a certain configuration of the dam. And then for one configuration, so for one case of the dam, it took 2 persons, 1 full month of work to do all these calculations and to figure out how the tides and how the water flow would behave. And this was used to choose the final positioning of the dam. And nowadays we would be able to do such kind of calculations very fast with a computer. So sometimes we need a computer to do certain complex calculations, and what we should learn as engineers is how we can use a computer to do these kind of things. And then at the time of early computers, people started making more and more sophisticated models. So here is an example of a piece of a model of a fluid flow, and in the middle there's a certain circular rod where the water flows past, and people started using computers to calculate how this flow would work and what the pressure on the side of this rod would be with a certain water flow passing past it. And such kind of models they evolved through many years of both research as well as evolution of computer systems. And nowadays we have quite sophisticated models to do different types of calculations. So here I want to show a few examples. This is an example of metal forming. So here you see a plate of steel from the car industry, and during stamping of this plate of steel, we get the side pane of a car, and so such a manufacturing process is nowadays being modeled in a computer in a computer software, and then such kind of models are used to improve the manufacturing system such that it will work accurately and without problems. So this is quite a sophisticated computer model. Here we see another example. There's also bulk metal forming. So here's some initial billet is deformed into a certain final shape, and also such a machine can be modeled in computer software as well in order to figure out all the forces in the machine, and also to figure out whether it's possible to reach the final shape of the desired product. And another example for this is from my own research. I'm also involved in metal forming, and here you see a metal forming demonstrator process. So it's a production process which was designed only for research, and in this process we produced a certain metal forming product. And what we did in this process is get a lot of data from different stages of the production process. So this final product is produced in different stages. So there's some deep drawing stage, there are some cutting stages, there are some bending stages, And from all these different stages, there are forces being measured, and you see in this animation at the bottom that uh, after each stamp of the stamping machine, all the products move to the next stage. And what we try to do is obtain data from this manufacturing system and obtain all the forces and use that to predict how the final products will exactly look like. So can we predict very accurately what this data looks like? And to do that, we need to program systems that are able to read this data, but also able to analyze the data and make predictions for what we expect to see in the manufacturing process. So these are all types of things that involve a lot of using the computer to do different calculations, and that also involves programming. So to recap, why is programming important for modern engineering? Well, it's important because it's used in advanced simulations, it's used in big data analysis, but also one thing which is very useful why we use computers to do these engineering calculations is we can also let our program optimize a certain design. So if we want to choose certain dimensions for a certain product, we can let the computer calculate how the product will behave or whether it will be strong enough for using a lot of different dimensions, and then we can select the dimensions which are, for example, of the lightest final product, but which is able to withstand all the loads on the system. So we can let the computer check a lot of different designs of our product that we are designing, and then we can use that to select the best design. And another nice thing of doing something like that with computers, it's also very efficient as we can even work at night. So it's very common to start your simulations, and sometimes if it's a large computation, you may have to wait for many hours, but the computer doesn't have to sleep. It can continue working at night, and hopefully the next morning back at work you'll have some interesting results to further analyze. So these are why this is why computer is indispensable and programming is indispensable in modern engineering. So and here I just want to mention one difference between, let's say, simulation software and programming. So a lot of these kind of calculations, also the simulations I've shown just before, can be created using very dedicated software. So for example, we have dedicated finite element software, which is able to do specific calculations about these metal forming processes that I've shown before. Well, in such software, usually you can do a lot without any programming. So you have to, like in using SolidWorks, you can design certain geometry, and you can tell the software how it will behave during manufacturing, and then the software will do the calculations. So you don't have to program all the equations yourself in order to solve that. So for more complicated calculations, there is specific software, but still there are often many types of calculations, sometimes more simple calculations, or where we do not have specific software for. So in that case, you will have to write your own code to solve these equations. And also sometimes the applicability of the simulation software is limited. So sometimes in your engineering job, you will want to extend the calculations of the simulation software with your own equations. So for example, if you're modeling metal forming, the simulation software will have models included about the material behavior of metals, but it may be that you need to include a certain model which is not made available by the software, and then quite often you are able to write your own user routine, which means that you're able to write your own small piece of code only related to, for example, this material behavior, and then you can plug your own piece of code into this simulation software. So, which tells you that writing code can be used in many different ways in engineering, and that's why we try to teach you the basics of programming throughout this first year of the mechanical engineering course. So, what's the objective of ModPro? Well, the objective is learn programming, and programming is a tool to solve engineering problems, and um, we will be using the MATLAB programming code and software to do so. And therefore, we want you to become very familiar with how MATLAB works. And um, that means that does not mean that you'll have to learn all the functions that are available in MATLAB, but it does mean that I want you to learn how to use the help function of MATLAB to figure out whatever you need for your specific code, and to figure out how to use all the functionality that is available by MATLAB in your programming. And the other objective is to gain experience in solving engineering problems. So in many of the exercises throughout this year, we will be solving a lot of different types of engineering problems, and modeling and programming is also about how to convert a certain problem into a model, and then how to translate this model into computer code and solve it. So as I said before, this the modeling and programming course is intended for people with and without experience in programming. I know that most of the mechanical engineering students don't have any experience in programming, and there's always a batch of students with some experience, and the number of students with a lot of experience in programming is usually quite small. But the course is intended for everyone, so everyone should have reached a certain level of programming skill at the end of the first year, because you will really need it later on, and even need it later on in your studies, because you will be making increasingly complex calculations, and you won't be able to do it all without any programming skill. The course also about engineering, so also people who already do have experience in programming will be challenged by the ways that we use programming to solve engineering problems. So now I'll show some examples about some of the things that we do in the modeling and programming course throughout the first year. So the modeling and programming course is a course which runs throughout the first 4 modules. I'll give some more explanation about the organization later, but here I'll show some examples from different modules. So here is an example how modeling and programming 1 is connected to statics. So in statics, we will be using a joint method to calculate the forces in trusses for a system in static equilibrium, and that's something that we learn to do by hand in statics, but with increasingly large systems, it's just a lot of work to do it by hand, and we can also plug these equations into our computer code and solve it with computer code. So this is one of the examples that will be done in the last session of the first modeling and programming course. And then in each module, the modeling and programming course is connected to a specific engineering course. So In the second and third module, it's connected to thermodynamics. So here you see an example of calculations which are performed within MATLAB about thermodynamic systems. So you will learn how to calculate the temperature and entropy in a turbine system, for example, and also how to output this and how to make such kind of graphs, such kind of plots. And then also in thermodynamics, we use Sankey and Grassmann diagrams. These diagrams are called, and these are kind of energy flow diagrams. And you will also learn how to code such energy flow diagrams in MATLAB and um, how to extract, so how to do the calculations and also how to how to visualize the results using MATLAB. Then here's an example of the third module. So in one of the sessions, we will calculate this mass spring system. So here are two masses, the red dots, and in between the masses we have three springs. So the bottom spring is fixed at this bottom position and the top spring is fixed at the top. So there's one string from the top to the first mass, and then one string in between the masses, and from the bottom mass to this bottom point. And by starting with a certain initial position and velocity of these masses, we can calculate how they move in time. So it's similar to what you have seen in the time lectures in your first week of studies, and we can do something similar with a mass, and that's an example of what we do in the modeling and programming course as well. And then, as modeling and programming, the third module is related to thermodynamics as well. We will also use MATLAB to calculate. Here we see enthalpy curves. You will learn in thermodynamics what entropy and enthalpy means, but here it's a certain diagram which tells us something uh, about the water and steam. So uh, here is a line, and if the combination of water and steam is within this uh, below this red line, then we have a mixture of water and steam, and at the top we have pure steam, and you will need to evaluate such diagrams in order to do thermodynamic calculations, and that's something that we will use MATLAB for. And then in one of the sessions of ModPro, you will also use these calculations to draw such a diagram yourself using MATLAB. So this is an example of some engineering calculations which can be done with MATLAB, and also an example of how to make clear and nice diagrams using MATLAB. And then in the last, so in the fourth module, here you see calculations of a similar bridge as we saw before, but now we will be able to do calculations on a statically overdeterminate bridge by including the deformations of the different beams in the calculations. So these kind of calculations are related to the mechanics of materials course. And in the fourth module, we will write a full finite element beams code, so a code which is able to do such kind of calculations on reasonably complex systems. So we will write a full program during the fourth module, which will need several sessions. So in the end, we will use 6 or 7 sessions to create this full code. So in the fourth module, we will continue to work on the same code during different sessions until we have this reasonably sophisticated code that can do these two-dimensional mechanics of materials computations. So in that sense, you see that the complexity of what we will be doing in the modeling and programming course will be gradually increasing throughout the year. So, and this another example, you will also be using a similar code to even analyze three-dimensional structures. And in the project from the fourth module, last year students had to design a certain crane, and then they used this code to analyze the deformations and the stresses in such a crane. And that's all things that we use our MATLAB code for. So let's talk about programming now. What is programming? Programming is a way to instruct a computer to perform various tasks. So it's a very general thing. So let's have a look at a certain example. In programming, we write code, so we write text, and by writing this text in a very specific way, we can tell our, in this case, MATLAB software, what we want the MATLAB software to calculate for us. So here we see a certain code, and I will use this code to explain a series of terms which are related to programming. And this code, it is about drawing a circle and telling us what the area of the circle is. So when we run the code, in the end, this will be the output given by MATLAB. So MATLAB will open a new window, and in this window, we will see this image of a circle, and it will tell that the area of the circle is 7.0686. So I want to discuss all these different terms which are related to programming. Let's start with a script. A script in MATLAB, it's a set of commands that we can give to MATLAB. So in a script, MATLAB is going to evaluate the different lines one by one. So it starts at the top line, and then it is going to evaluate all these lines one by one. And when it's finished with a certain line, it will proceed to the next one until it has evaluated all these lines. And then each line, it will do something. So each line has a command. So here I neglect the green lines, because these are commands, I will explain them soon. But here we see 6 different commands, and each command is evaluated by MATLAB one by one. So MATLAB starts at command 1, then command 2, and so on. So let's have a quick look at these commands. So if you run a MATLAB script, then all these commands will be evaluated one by one. So what MATLAB will do is it will first evaluate the first line. And here a variable named radius is created, and a value of 1.5 is given to it. I will shortly after this, I will explain what an assignment and what a variable is, but this means that MATLAB will remember this value of 1.5 such that it can be used later in the code. So once this radius of 1.5 is stored, then we evaluate the second line where the area of a circle is calculated, and for that we multiply pi times radius, so pi times radius squared. Then we go to the third command. In this case, we want to draw the circle. We use a command which is called rectangle, which is a bit odd, but in this case it can be used by MATLAB because we can define a rectangle, but we can give a certain curvature to the edges of the rectangle. So this is a MATLAB command which is suitable to draw this circle. And in this case, MATLAB evaluates this command, so it draws this circle. Then we go to the next command, and this is the axis command. So the axis command is able to change the axis. So here you see the x-axis and the y-axis of our plot, so of the figure that was created by MATLAB. And so by evaluating this axis command, we zoom out. So at first we saw this circle, and then another command is evaluated, so MATLAB changes this figure. So what I want to show here mainly is how things are evaluated one by MATLAB, and your task will be to provide all the commands to MATLAB in the correct order, such that it gives you the desired output. So in this case, there's a fifth command which is called access equal, which makes that because the size of this figure is rectangular, so this circle doesn't look really round. It's more some kind of oval. So with access equal, we can fix that. Another MATLAB command, and then there's another MATLAB command which is called title, and we can provide a certain title to MATLAB. So now it says area of circle is 7.0686. So these are commands and they're evaluated one by one. So so sometimes we talk about a statement. So a command and a statement are the same. They have the same meaning. Okay, and then another thing that we have in our code is a command. So in MATLAB, we can include command lines by adding a percentage sign at the beginning of the line, which means that if we write this percentage sign and then we write something thereafter, then MATLAB will skip this line in evaluating it. So here we saw that these 6 lines were being evaluated, but these 3 green lines, they are not being evaluated by MATLAB because we have defined it to be a command line. And why do we write commands? If you don't do that, then it will be very hard to understand what you're doing. So we need to include commands in our code to make it readable, because otherwise it's very difficult to figure out where something may be incorrect in the code, or how to figure out how to even improve the code even more. So these are commands. Then we have variables, and variables, they are defined with a certain name. So a variable has a certain name, and the name is free to choose by yourself, and it has a certain value. So here in this case we have used 2 different variables. We use the radius variable, which is used in line 1, line 2, line 3, and line 4, and we use the area circle variable, which is used in line 2 and line 6. And a variable, it is like a box in the memory of MATLAB, and it has a certain name. So if we use that name in our code, then MATLAB knows where to search for the information that we're looking for. And it has a certain value. So a value can be there are different types of variables, so it can also be some text or a number, but it always has a certain name and a certain value. So here on line 1, we give the value 1.5 to the variable radius. After evaluating this line, MATLAB will remember that when we type radius, that it has to search in a certain part of its own memory, and then it will find the number 1.5, and then it can use that number 1.5 to do another calculation. So after finishing this line 1, it will have stored this number 1.5 in a certain part of its own memory, and then when entering this second line, it sees that you want to calculate pi times radius, and then it will search in its own memory what is in the radius box. In this case, it's 1.5 because we have just defined that. So it will plug this 1.5 times 1.5 in this line. It will do the calculation, and it will put the result in the area circle. So these are variables. So boxes in the memory of MATLAB. Sorry. Then the assignment. With an assignment, we mean putting something in the memory of MATLAB. So in MATLAB, an assignment is always written with an equal sign. So where you see an equal sign in MATLAB, it means a certain value will be assigned to a variable. So if you look at the assignment, it's always at the right side, you see what MATLAB has to do to get a certain value. So at line 1, at the right side, we see 1.5. So MATLAB has to get 1.5. At second line, we see pi times radius times radius. So MATLAB has to find out what the current value of radius is. And then it has to multiply it with itself and with pi and generate a number. And then what we see on the left side of the assignment is in which variable MATLAB has to store it. So in which part of the memory this result has to be stored. So in the first line, the value of 1.5 is being assigned to the variable radius. And in the second line, the result of the calculation pi times 1.5 times 1.5 will be assigned to the variable area circle, which means that after evaluating these two lines, MATLAB will have two boxes in its memory with certain values in these boxes. This is an assignment, and using assignment, let's say usually 80 or 90% of your code consists of assignment. So doing a calculation and storing the result in a certain variable, and then doing another calculation, maybe using the same variable that you have just figured out the value of, and then do a new calculation and again store the result in another variable. So a lot of the code will be assignments. Then we have data types. So we spoke about variables, and there are many types of variables. So here, for example, these things that you see underlined now are all numbers or lists of numbers. So this 1.5, this is 7.06, and this is a list. And in this case, the list is created by multiplying this list, which is -1, -1, 2, 2, with the radius. So if we multiply all these numbers with 1.5, we will have -1.5, -1.5, 3, and 3. So this is a list of numbers. Now here again, we have a number 1. Again, here we will have a certain list of numbers, which will be 1.2 times the radius times these numbers. And here, this is also a number because in area circle we had inserted this number. So these are variables which are numbers. So that's one type of data that MATLAB can store in its memory. But MATLAB has more types of data. Another type of data are, for example, strings. So pieces of a set of characters which together form a word or a sentence. And by this, using this top apostrophe, we can define something as a string. So um, this is a text, and this text can be stored in the MATLAB memory. And here we don't store it in the MATLAB memory, but we do pass such a data type to this function in this case. But the main thing is that such a set of characters, it can be it's a type of data that can be stored by MATLAB in its memory as well. So here we see different types of or different sets of strings. And then here in this last part, as the title needs to be a set of strings, so it doesn't have to be a number, but a set of strings. So here a certain function is used to convert the number that we have. So it's called num to string. So it converts a number into a string. So with this function, a data type number can be converted to another data type. These are quite some details, so you will learn about it later, but the main thing is to remember that there are more things than numbers. There's also, for example, text, and also Boolean variables is something that you will learn to use. So let's say, tell whether something is true or false is something that we store in a Boolean variable, and that can also be stored in the MATLAB memory. So there are different types of data that can be stored in the MATLAB memory. And then sometimes data is a single number. So for example, this radius is a single number, but in MATLAB we also use a lot of arrays, which is for now you can think of arrays as just being a list of a table full of numbers. So like you can in Word or Excel, you can make a table of a certain size and you can fill all the fields of the table with numbers. We can also do the same in MATLAB, and we do that to store a lot of data that belongs together, to store it together in a certain variable. So you could uh, imagine that if you have an area of the sea that and if you see it from the top view, it's actually a two-dimensional data set. So at each xy coordinate, you can get the depth of the sea. So we could generate a depth variable, which is where the depths at different positions are then stored in a table, um, which is called an array in MATLAB. So an array is a list or table of data, most often numbers, but sometimes we can also even put other types of data in an array. And then there's something like a function. A function is written with, it starts with writing the function name. So in this case, rectangle, it's a function, it's a MATLAB function. And then we have these standard curved brackets, and then we give all the things that the function has to know. So in this case, we tell it that we want to define the position, that the position is defined by certain numbers, and then that we want to define the curvature, and that the curvature is defined with a number, and then we close the bracket again. So what this function does is it uses the input arguments. So all the things that we give to the function are called the input arguments, and it evaluates them in a certain way. So the rectangle will use these input arguments to draw a rectangle in a figure. The axis will use certain input arguments to, for example, change the size of the axis, and the title function will use this input argument to write a certain text on top of a figure that we have created. So each function has a certain task, and what we should do is we should provide the right code to the function, so the right input argument, such that it is able to do the task exactly in the way that we want it to. So MATLAB has a lot of functions that can be used. And if you would look at the function within MATLAB, for example, so some functions you can even open. So this is the title function, and then inside this function, again, there's a lot of code that is MATLAB code as well, where which is being evaluated when the title function is being used. Well, you don't need to use this code, which is inside these MATLAB functions. What you need to do is learn how to use the help function to figure out how to use the function, but you don't need to really dive into this MATLAB code from the function, which is findable, but is not of use for you. But what you will learn later in the second module is how to write your own function files. So you will write code and write our own functions that then can be used in our codes. And then there's syntax. And syntax is a very important term because it refers to the exact way to write something and to give a command, provide a command to the computer. So What MATLAB does is it reads each line of text that we have written one by one, and then it converts this line into a certain task that it has to perform. In order to do so, we must very precisely follow the instructions about how such a line must be written. Because if we do it slightly different, then MATLAB will not be able to evaluate it. So there's a very precise syntax, a very precise way in which such a line has to be evaluated. And for that, we need to learn to use the help function. And for now, I will show one example. So in this code, we use this rectangle function, and MATLAB has a very extensive help function where it exactly explains how everything has to be, how all the functions provided can be used. So if we would open the MATLAB help function, when we would go to the page where the rectangle function is explained, then we will see this. And we will see the syntax, and there are different lines. So this tells us that there are different ways in which the rectangle function can be used. And in my case, in this example case, I used the example using both a position and then with a position value and a curvature with a curvature value. So what we see, and then we see in the description what it means. So um, if we read here at the bottom, it says if we write it exactly in this way, it will add curvature to the sides of the rectangle. Okay, so here we see that this explanation is about the second part of the code. So it's about this curvature part of the syntax. So first we can also read the description for the first part. So here it says rectangle. If we use the command rectangle and then write this apostrophe position apostrophe comma and then a certain variable, close brackets. If we do that exactly, then it creates a rectangle in two-dimensional coordinates. And here it tells us specify pos, so this variable pos should be specified as a four-element vector of the form square brackets, a certain x position, a certain y position, a certain width, and a certain height. So that is the type of variable that we have here. So we have square brackets. So we have a list of four numbers. So if you multiply radius with these four numbers, we still have a list of four numbers. And that's what we plug into this function. And then it will create this rectangle. And then this is just to create a rectangle. So if you would do only that, then it would not be a circle, but it would be a rectangle. So we can add a certain curvature to the sides of the rectangle, and we have to specify a certain value in between 0 with no curvature and 1 maximum curvature. And if we specify a curvature of 1, we will get maximum curvature, so it will create an ellipse or a circle. So in this case, it's a circle that we created. So in the MATLAB help, it tells us exactly how to use such, how to specify the syntax for a certain function, for example. So, and then in the MATLAB help function, there are always examples. So if you don't understand this, you can click on example and you will see an example of how to use it. So one of the most important things to learn in using MATLAB is to properly learn to use the help function. The help function, if you figure out by using it how it works and what information it gives you, then it will make your life much, much easier instead of trial and error trying to do things yourself. So this is syntax. Syntax means you have to write a certain line in a very precise way. Then there's another term, algorithm, and algorithm is a method for doing a certain calculation. So if you can think, for example, about if you have a series of numbers and you want to sort them from the lowest to the largest. So you have for example, a stack of papers, and on each paper there's a number written on it, and you want to put them in the correct order. Well, intuitively, one of the things that you could do is go through the stack of papers and search for the lowest number, and then put that on the the top of your sorted pack, and then go through the list of papers, the stack of papers again, and search for the now lowest number. And then once you found that, put it on your sorted stack again. So this is some kind of procedure that you can repeat to in the end end up with your sorted list. Well, this is the procedure called selection. You can figure out that it's quite an inefficient procedure. So another thing that you can do is, for example, get the first paper from your unsorted stack, put it in your sorted stack. Then get the second paper from your unsorted stack and put it in the correct position of your sorted stack. Then get the third paper from your unsorted stack, put it in the right position of your sorted stack. Well, that's, for example, called the insertion algorithm, which shows you that sometimes there are different ways to solve the same problem. And an algorithm is a very clearly defined way to solve a certain problem. And sometimes it's relevant. I want to show this here, so I will click, and then you will see that all these sorting algorithms, so there are 8 sorting algorithms, will start to work on this list of unsorted numbers, and they will sort them, and some of them will be more efficient than others. So that's so here you see that different algorithms work in different ways, and some of them are much more efficient than others. So an algorithm is a certain procedure that is invented to solve a certain task, and sometimes we will do it in the straightforward way, and sometimes we have to come up with some smarter things to do it in a more efficient way. Then another important term is the error. So if we write a code but we make a mistake in the code, then we will have errors. And mainly there are 2 kinds of errors. So one thing is if we make a mistake in our code. So for example, here I have changed this code and I've set the curvature to 2. But in our help function, we have already seen that curvature must have a value in between 0 or 1. And if we do this and we run this code, then MATLAB will complain. So it will give this error message. And the most important things with error message, and that's what people somehow forget sometimes, but the most important thing is read the error message. So in this case, it says value must be either a scalar of type double, a vector of type double in the range 0.1. So here we already are able to read that it should be in the range of 0.1, of 0 to 1, so we can, and it doesn't specify exactly which variable should be in this range, but at least we see that the error is caused by the rectangle, so we can check the help function of rectangle to check which of the values must be in this range. Sometimes people forget to read the error, so if there's a mistake, there's an error, and then they try to fix something, but always it sounds very obvious. It is quite obvious, but don't always check the error and then think, using the error, think about what may be wrong in your code. And then in the error, it also tells you in which part of the code there is a certain mistake. So here it tells you it's on the 6th line. So this line 1, 2, 3, 4, 5, 6. So on this line, so for this command, there's an error. So use that. Another type of error is just an error where you make a certain mistake where MATLAB doesn't care about. So we're doing calculations. So we're given equations to MATLAB, but MATLAB is not an engineer, doesn't have any mathematics degree, so MATLAB does not care whatever you provide it with. So if you would say that the area of a circle is pi times radius, it is a wrong calculation, but MATLAB does not care. So here we will see a result area of the circuit is 4.7. So which tells us that it's easy to make mistakes in the calculation, and it's your task to verify whether the results are correct. So always have a very critical eye to your results and have a look at it and think about whether it is what you expect, and if it's not what you expect, then it's very probable that you may have made some errors in the equations. And MATLAB will not complain about wrong equations, it will only complain about errors in syntax or using the wrong variables uh, at, in your code. So it will only complain if it's not able to proceed with the calculations, but in this case it's perfectly able to proceed with the wrong result of the area circle calculation. So there are two kinds of errors. And then last thing, code. When we talk about code, we just talk about all of these things that you write in MATLAB. So this is all code, and that's what you will be learning to write proper code um, for doing engineering calculations. So now let's have a look at the organization of ModPro. As I mentioned, ModPro is a course which is given throughout the full first year. So in all the 4 quartiles, we do ModPro. In the first 2 quartiles, the ModPro part of the course is valid 1 EC, and the third and fourth it's valid 1.5 EC. So in total, it's 5 credits which are devoted to learning to program. And in each module, the modeling and programming course is connected to one of the engineering courses. So in the first course module, it is statics and modeling and programming 1. That's the course. In the second module and the third module, it's connected to engineering thermodynamics. And in the fourth module, it's connected to mechanics of materials. In the content of the models, it will be this of a very rough description, but in the first module, we will start with basics of programming in MATLAB, plotting, solving linear equations. So what we do in statics is solving linear equations, and we will also use MATLAB to do that. In the second module, we will go towards writing our own functions. We will do some more advanced plotting. We will also use some code which is specifically used for thermodynamic calculations. And then in the third module, we will proceed by also learning about some numerical solution methods, about learning how to use functionality from MATLAB for optimizing problems. And then in the fourth module, we will write our own beam finite element program. So we will focus very much on the mechanics of materials content, and throughout multiple sessions we will write a reasonably extensive code for beam calculations. So the level of ModPro also evolves over the different models. So we start with the first module assuming that there are quite some people without any experience in programming. So we start with getting the first basic level of knowledge, and then in the following modules the level increases. And in the second module the level increases, but the exercises are still pretty much guided, which means that in the exercises you will be told step by step which steps have to be taken in order to end up with a certain end result. But in the third module, the exercise will become more open. So after a certain amount of modeling and programming practice, the exercises will go towards telling you what kind of end result we want to find, and then you'll have to think yourself which steps have to be taken to get that end result, and how to put these steps into programming code. And it will end in the fourth module with writing a full program, so quite an extensive program during multiple sessions. So here you can see that the level increases over the modules, which also means that the knowledge from previous modules is always a prerequisite for every new ModPro course. So if you manage to fall behind in the first module, then you will have an increasing troubles in later modules to catch up with ModPro. Uh, so that's a pitfall, and in the end we will do reasonably complex things. So try to keep up with it, and also try to where you don't manage to do so, please also contact me, and then we can figure out what would be helpful for you in order to keep up with the speed of the course. So, and then in each module there will be an examination. So the course grade, it's a combined course with the engineering course that's coupled to it. So in the first module, you will get one final grade for statics and modeling and programming 1. And then it depends on the module how that's combined. So in the first and the third module, there will be a programming exam, so where you have to bring your own laptop and do some programming exercises, and for that you will receive a grade, and this grade will be combined with the statics grade. In the case of statics, it's 1/3 ModPro grade and 2/3 statics grade, and that will be your total grade. Where you have to get a 5.5 at minimum for each subgrade. So both for modeling and programming 1 as well as for statics, you should get a 5.5 at minimum. That's what happens in the first and third module, and for the second and fourth module, we'll do some kind of case, which means that you will get an assignment, and you will be allowed to do the assignment in pairs. And after submitting the assignment, you will receive either a fail or a pass, or you can even receive a bonus point for your final grade of that specific course. So for example, for the Engineering Thermodynamics 1 and ModPro 2 course, you can get a bonus point if you do the extended version of the case in a proper way. So for 2 of the modules, we will finish it with a case, and for 2 of the modules, we will finish it with an exam. So each module we will have, in this case, we'll have one lectures. Some modules we won't even have lectures, but we only have practical sessions. So we'll have, let's say, 4 to 10 practical sessions in each module. There will be a short explanation, and for now, as the education is online, it will be a video, and then there will be self-explanatory assignments. So from Canvas, you will be able to download usually 2 PDF files, one with some explanation and one with the assignments or with the exercises, and then you can start making these exercises. During these sessions, there will be teaching assistants available. So they are here to help you where you get stuck, and you will get stuck because everything is new, and MATLAB requires precise syntax. So if you're not able to find the precise solution, then you need help. So make use of the teaching assistants. So to help you forward. And for now, these we will be on the Discord server, and hopefully later on in the year we will be able to have at least some sessions at the UT where we can explain things face to face. And then after each session, I share the solutions over on Canvas. So for the things that you were not able to figure out, you can check it how your solution compares to the solution that I have made for these exercises. So try to use these solutions to check what you've done, but don't use these solutions to do the exercises, because especially in the case of programming, you won't learn from it by looking at the solutions. You really have to go through the process of thinking what you need and thinking where to find the answer. You've got to go through that process yourself. Um, then in the end, there's a test or a case, as I explained before. For the exams, you need a 5.5 grade at minimum. And here I also want to mention that um, during the course, you're allowed to collaborate with other students. It's a very good thing to try to learn things together. Sometimes you may want to share your solutions with your fellow students in order to learn from each other, and that's a good thing to do. But it is very obvious, but I still want to mention it, um, is the exam and the cases should be made by yourself only. So you're not allowed to share solutions with other students during the exam or while making the case. And in the case, of course, you do it in pairs. So each pair should write its own solution of the assignment. And also for the test, everyone writes his own solution of the test. The best way to make if you master this programming, the best way to make a test is just to write the code from scratch during the test. But you're allowed to look at your MATLAB solutions that you have made yourself during the test. And although I really do not advise to do so, because if you really master programming, you should just write your code from scratch during the exams. Sometimes people use old solutions and then try to transfer it into the exam answer, which is usually not so efficient, um, but still people do it. Um, in that case, you should be aware that you should be very careful with using files that you have gotten from other people as well. So and what happens every year is that um, we are able to find some students which have clearly exchanged files which were used in the exam. So by comparing different exams, um, it is there are some obvious cases where there has been some sharing of files, and then I will always check with you um, how this happened and why it comes that different solutions are quite same. And sometimes it is because people were tempted to share solutions during the exam. That's fraud. That's really not allowed. And we manage to catch these cases every year. So really be aware that you should make your own exam, and you should, although when working on a laptop, it may be reasonably easy and tempting to share things with other students. It's very important not to do it. And in the test, we want to examine your skill in programming. And if you have not reached the skill to pass the test at that moment, then you will just fail the test. But failing a test is much a better thing to do than having to explain a fraud case to the examination board. So I just want to tell you, you're allowed to work together uh, uh, during the module, but you're not allowed to work together during the exam case with other students. So, and then one last thing to mention is Canvas is the main source of information, so all the information about the course will be provided there. Then on Canvas, I will also share a cheat sheet. This cheat sheet is not fully developed, but it is a sheet, and A4 sheet with a lot of standard MATLAB functions. So please go through it, have a look at it, and it gives the use of many different commands, and also using arrays, so using vectors and tables of data. It explains a lot of things. So for many basic things, it's you can find how to use it on this cheat sheet. So I hope it helps, and it's not really finished, but as a start, I think it can be quite helpful to find some things. And then another thing is that sometimes people ask for some additional resources, and especially if you're not experienced with programming at all, it may be at times you may have some problem in starting with this whole use of MATLAB. And if that's the case, I would advise you um, to go to the MATLAB Academy of MathWorks, and then at least try to follow this MATLAB on-ramp course. So in this course, the basics of MATLAB are being explained. So it's quite similar to what is being done in the ModPro course, but it's being explained even with smaller steps in a very basic way. So if you have problems with catching up with the first parts of the ModPro course, this may be a very useful investment of let's say 2 to 3 hours in total to understand the basic ideas of MATLAB, and this is just an investment which may help you very much to get the first basic concepts in your head, and then proceed with the ModPro course uh, to start doing increasingly complicated things with MATLAB. So for this MATLAB on-ramp course, I have mentioned in each session which part of it is useful for that specific session. So if you want, you can do this as an extra in order to make sure that you grasp what is being done in these first few sessions of the ModPro course. To use this MATLAB Academy, you must log in to MathWorks website using the account that you have created when installing MATLAB. Then here's my email address. Here's my office is in the Horstring. So please feel free to contact me. And also feedback about the course is very much appreciated. So if you have feedback about the content, about the exercises, about the level, about where it's hard to keep up with it and what it's easy or not so easy to understand, yeah, I'm happy to hear from you about it. So I try to use that feedback to improve the course from year to year. So feel free to provide me with some feedback. And then for now, I think it's a good moment to pause this video if you haven't done it before, but it may be a good moment for a break. So get some coffee and off, and the rest of this video I will explain some things about MATLAB itself. So let's talk about MATLAB. So in this course, we are using the MATLAB software for programming, and MATLAB, it stands for Matrix Laboratory. And a matrix is in fact an array with numbers. It's a table with numbers, and what the name tells us is that MATLAB is very efficient with doing calculations with numbers. So it's not the programming code which will be used for developing software or whatsoever. For that, there's other programming codes, but MATLAB is very much used in research and engineering to do calculations, and MATLAB can do that very efficiently. So it can process large matrices with a lot of data and do large calculations in a reasonably efficient way. That's why it's called MATLAB. It's an interpreted language, which means that MATLAB will what a programming language has to do is translate the syntax that we have, so the code that we have, it has to translate it into something that the computer understands. So which means that is some computer code which consists of zeros and ones. So on the right hand side you see the code that the computer understands and is able to evaluate, and it has to be compiled. So it has your software, so the MATLAB software has to compile this code into the computer code. And interpreted languages means that MATLAB does that line by line. So when it's evaluating the code, it compiles it line by line into computer code and then lets the computer evaluate that command. Whereas a lot of programming languages, this happens for the whole code all at once, and then after that it's gonna be evaluated. So it's somehow a different class of programming language, and well, in the case of MATLAB, it is efficient because compiling a large program sometimes takes a lot of time, and now it happens while evaluating the code line by line. So it's a class of programming language which is called an interpreted language. And MATLAB has a lot of functionality and toolboxes, and there are quite some people using MATLAB, so it has a large user base. That's why MATLAB is a very nice program to use. So if you want to perform a certain task, then either MATLAB may already have the functions, the functionality to do so, so you only have to look what the syntax is within MATLAB to perform that task. So for example, draw a circle on your screen. There's already this task, but also, for example, if we want to sort a list, we don't need to write the code to sort the numbers, but we can search for the sort function in MATLAB, and then we can use this functionality of MATLAB. It also has toolboxes. Toolboxes are kind of specific functionality for very specific tasks, and MATLAB has a huge number of toolboxes, for example, for image processing, or for dynamic calculations, or for many different types of tasks. There are these very specific toolboxes. In ModPro we won't use these toolboxes, but it's one of the reasons that MATLAB is reasonably popular, is that it has the availability over a lot of functionality and toolboxes. It's developed by MathWorks, so it's a company, which means that we need licensing for it, so we need to pay money in order to use MATLAB. And that's why I just want to show you this alternative. That's not an alternative that we will be using in the mechanical engineering course, but it is an alternative which is widely used in especially small or medium-sized engineering companies, because this is an alternative which is free to use. It's called Python. It was invented by someone in the Netherlands, by Guido van Rossum, many years ago, and it is increasingly popular, and it is quite similar to MATLAB in the sense that it's an easy to learn interpreter language. It has its own syntax, so the syntax of MATLAB is not precisely the same as the syntax of Python, but once you have learned to use MATLAB, it should be reasonably easy to learn to use Python as well, which means that if you learn to use MATLAB during your studies, and you end up at a smaller company which is not willing to buy these expensive MATLAB licenses for companies, then you may end up using Python as well, where you will be doing something similar but just in slightly different code. Again, also Python has a large user base, so which means that there's a lot of people creating specific functions for specific tasks. So that's useful because if you need to perform a certain task, you often don't have to write the code yourself, but you can search online for the functions that you have to that you can use. So it has a lot of functionality as well. And the advantage is indeed Python is free. So here's just a graph to show on the Stack Overflow website, which is a website where people ask programming questions. How much questions are being asked for different widely used languages, and you see that there are questions about MATLAB as well, but that's less than 1% here, and you see that Python has been really growing in the recent years, so it's a widely used language in programming. So not only in engineering, but also in other fields, Python is being used as well. So just to point out a certain alternative to MATLAB, which you may encounter later in your life as well. So in the comparison, indeed, MATLAB may be a bit easier to use, may have a bit more toolboxes. Whether one is faster or not, it really depends on the application. And the disadvantage of MATLAB is that it costs more money. And then one of the things that why do we still use MATLAB in the mechanical engineering courses? It has certain toolboxes such as Simulink, which is what you see here. It's a certain toolbox which is very easy to do calculations on dynamic systems. So this is something that you will appear later in your studies. And Python doesn't have something similar yet, at least. So that's also why for now, we prefer to use MATLAB in the mechanical engineering study. So let's have a look at the MATLAB window. So once you have installed MATLAB and you open it, you will see something like this. And I will explain all the different parts of this window that you see here. At first, you see the current folder. So here you see that I'm working in the C/users/ my name /document/education /modpro and so on folder. So when you're working in MATLAB, you're working within a specific folder. And within that folder, MATLAB will look for the functions that you have, and then you will be able to use these functions. So this is the folder that I'm working on, and this is the content of that folder. So in that folder, I have a lot of files, and all the files which are called .m are MATLAB files, and there are some other files as well. So this is my current folder. And then if I click on one of the files, sometimes I can see details about the files in this part of the window. Then here in the center, we will have the editor. And this is let's say, the standard position of the editor, but you're allowed to rearrange everything. You're allowed even to create a separate window for the editor if you want. But standard, you see the editor here. And the editor is just the window in which you can open all your files and you can type your code. So here you see that I have 5 files opened, and in these files I can change my code. And this is the code that we have seen before. So this is the window in which we type. Then here we see the command window, and in the command window we can evaluate single commands. So instead of evaluating a series of commands by evaluating such a script, we can evaluate only one command in the command window. Also, when this function will give some output, it also shows the output in the command window. So in the command window, we see all the separate commands that we have evaluated, and we will use it very much to also, for example, check values of a variable. So if you would type area circle here and then press enter, it will show us the value of the area circle. So this is the command window. Then this is the workspace at this right-hand side. So here you see that there are some names. So these are the variables which are currently in the memory of MATLAB. So MATLAB has some boxes in its memory, and these have different names, and in each box has a certain value. Of this one has a table of 100 different values. So this is a place in the memory of MATLAB, and at the right hand side you see which value is stored in that place. If you double click on one of these values, you can also, it opens a window here in the center as well, and then you can see all these values which are stored in the variable hoi, in this case, as well. So this is the workspace, we call it, and the workspace contains all the variables and its values. And then here at the bottom, we have the command history. So these are all the commands that you have used in the recent past within MATLAB. So if you want to search for something that you have used recently, again, you can search in here. So this is what you see when you open MATLAB. And at the top, there's this MATLAB ribbon, and you see here that there are different ribbons. So one for home, plots, apps, editor, publish, view. And in the home ribbon, we can open a new file, we can import data, and um, we can also here by clicking on the layout button here, we can change which of these sub windows are visible and which are not. And then that's something that you will I will show in the first video for the first session as well. Here, if you look at the editor tab, you will be able to run this specific code. So here are different tabs, and just click through them once just to have an idea of what you find in the MATLAB window. Then some things about, in general, what's a good way to programming. First thing always is use the help function. It's very important to get to know how to use the help function, because MATLAB has a very good help function, and it tells you for all its functionality exactly how to use it, also with a lot of examples. So if you don't manage to understand the syntax exactly, copy the examples and have a look at what it does, have a look at what happens if you change some values. So you should be become very used to consulting the MATLAB help function. That's extremely important. Another very important thing is learn to work step by step. So learn to write a small part of your code and then run your code and check that the output is what you expect. And in later sessions, you will, and also in later modules, you will be asked to do more and more complex things. And sometimes you need to write more code in order to perform a certain task. And if you want to write the full code correctly in one go, then your chance of making mistakes and failure will be much, much higher. So try to work step by step. So code every sub-step, then run your code and check that this sub-step does what you want it to do. And once you're sure that it works correctly, you can proceed to the next step. This is a very important other remark. And then another thing is try to write readable code. So you will be allowed to choose your own variable names. Try to use variable names which tell what they mean, and also include comments in your code. So include text within your code that explains to yourself what you're doing, but also to your project group members. For example, if you share code, then it's very useful to have good comments, because then other people can work with your code as well. So this is very important in good programming. Then on Canvas, it's mentioned how to install MATLAB. Make sure to install MATLAB before the first practical sessions, and make sure to do it in time, because downloading and installing takes quite some time. And then in the practical sessions, there will be most of the times there will be a short instruction video which will give you some ideas about what to do, and then you just have to download the instructions, so the PDFs from Canvas, and start working. And then there will be an explanation PDF, and there will be a exercise PDF, and in the exercise PDF it will tell you when to read which part of the explanation PDF, and then you can start doing the exercises. Again, make sure to use the help function. So if you want to figure out how to do it, I'm provide different resources, also the cheat sheet and the explanation and the help function. Try to use them to find out what to do, because the main skill that you have to learn is not to memorize all the MATLAB syntaxes, but to understand where to find it. Um, and then the last thing is make sure to ask questions. So unfortunately, we have to do it online for now, so it will be on a Discord server, but there will be teaching assistants to help you. To ask questions in programming, it's helpful to be able to share your screen. So for Discord, it means that it's helpful to install Discord on your laptop as well. So don't use the browser version, because that does not support sharing your screen. And then if you get stuck, do ask questions, because you don't want to get stuck on the same problem for too long. And by asking questions, the teaching assistants and myself will be able to figure out which part of the topic you're not understanding so well, and then we will be able to give you some specific additional explanation. Um, so if you get stuck, please don't hesitate and contact us over the Discord server. It's very important to ask questions in order uh, to learn. And then the last thing that I want to say is good luck with the course, and please contact me if you have any questions.